We can also make esters starting with anhydrides. Again, probably not as common as the Fischer esterification, but certainly a valid way to do it if needed. Now, the most important thing to take into account is that whatever anhydride you're using has to be symmetric. What do we mean by that? We mean that the two R groups here have to be the same. If you choose an anhydride with two different R groups, especially if the two R groups are similar, such as these two, and let's say we added methanol, given the similarity of the two sides of this anhydride, there's no reason to expect a high preference for one side over the other. And there's every reason to expect that we could get a mixture of two different products. And that's not ideal for most reactions. So generally we'd like to pick this reaction in such a way that we get just a single product. And as we said, that's not a problem here. We just need to make sure we choose a symmetrical anhydride. Once we've done that, then we pick our alcohol. And we'll see, if you're familiar with acyl substitution reactions, a very, very familiar looking mechanism. In fact, if you're familiar with the esterification of acid chlorides, this is the exact same mechanism, just with a different leaving group. As is often the case with anhydrides, they're already activated by the better leaving group, and so we can use weaker nucleophiles, such as the alcohol itself, without the need for additional activation as we had to in the Fischer esterification. So here we just get that the oxygen will do nucleophilic attack on the carbonyl. That forms the very common tetrahedral intermediate. That tetrahedral intermediate breaks down by reformation of the carbonyl. And then we form the ester upon loss of the proton. So again, some positives over the Fischer esterification is that we can get away with more mild conditions. We don't need to activate the carbonyl with strong acid. Two major negatives here as well, though. One is that it's extra steps. We have to first make the anhydride in many cases. Although if you needed something simple like acetic anhydride, that's something you can purchase. The other negative is that basically half of the anhydride, that piece that I've circled in green, essentially gets wasted. It will not form an ester because it's lost as a negatively charged leaving group. It's not going to be an electrophile at all. And so the atom economy on this reaction is actually often pretty bad compared to other reactions. In other words, we have this anhydride that we start with, and half of that anhydride ends up getting thrown away. And so if you're at all interested in the area of green chemistry, which is the idea of looking at reactions in a more environmentally friendly way, The anhydride's probably not the best choice because we're going to end up disposing of a significant amount of our starting material. But as we said, sometimes that has to be weighed off against the positives, which that this reaction requires less harsh conditions.